And now we continue. We go to the next speaker, so to André Bechem. So André is from Heaten, Germany. He is the VP, Vice President of Sales and Product Management at Heaten. His background is engineering and technical sales and has done many application studies, energy solutions, complex integrations, all in all for a sustainable future. Before, Andre worked also in other companies like Climeworks or Viking Heat Engines, which was mainly, I think, the original company developing high temperature heat pump compressors. So Andre has a master in energy and process engineering, so from Ruhr University in Bochum, so from Germany, and a lot of international experience, also from Shanghai, from China. So interesting. I'm sure you will give us a nice overview of Heaten's perspective on steam generating heat pumps. Andre, the stage is yours.
Yeah, hello everyone, and first of all, thank you, Corin, for the nice introduction, for the kind introduction, and thank you also for the opportunity to present Heaten and our technology. So, steam generating heat pumps is a topic for today. Let's have a quick look into the agenda. So first of all, we talk about Heaten and the heat booster technology in itself, and then I think even more exciting for most of the audience is we talking about high temperature heat pumps in action. Lastly, I will wrap it up quickly and summarize what I have presented. Corin, you mentioned this already in the beginning. Behind Heaten, there is a long history. I do not want to go in each details, but let me highlight a few things. So in 2010, already the journey started with the development of a high temperature heat pump expander, back in the days made for the ORC technology, so organic rankine cycle, the reverse cycle, so converting thermal power into electricity. And from day one, the specification was clear that it should be able to run up to 215 degrees outlet temperature of the compressor. There was an intensive pilots and testbed testing before that, and then it was deployed into the market around the world. In 2015, actually, due to, let's say, the lack of market for ORC technology, the idea was born to make the reverse cycle, so to turn around the piston expander as piston compressor, modify especially the cylinder head, and from 2017, then the heat pump started to involving, and in 2019 you can see the pictures below. There are the first high temperature heat pumps delivered to the market, and these machines some of them are still running, so they have now collected even more than 50,000 hours. The 40,000 hours are from last year, so they are continuous running. And they already serve applications up to 220 degrees, and the technology itself with high HFOs back in the days could make up to 165 degrees. Then Heaten took over and clearly focusing on bringing this technology to a larger scale, because back in the days it was 250 kilowatt per machine. That was way too small. And with the Heat Booster Large series, so HBL4, and also next year with the HBL16, which you can see on the picture below, we are now really in the megawatt range. And after intensively testing, we delivered the first machine into the market. This was happening in November last year. And now what you will also see later on, we have now even more reference cases, and also aiming to of course have many more reference cases until end of next year. And also what you see down there on the picture, we are also introducing a bigger test bed, which will be at Jenbach, where INNIO is located. Now, maybe a few of you will ask, okay, why Jenbach? So here is the reason behind it. We have a strategic partnership. Like each startup in the past, we were financed until the next milestone, and this now have completely changed. We were acquired by Advent International last October, and Advent International is a financial private equity fund, and they also acquired in 2018 from General Electric the Inyo Jenbacher Group. And that's the reason this is now a strategic investment through a strategic partnership with Inyo Jenbacher. And you see directly on the first glance that, of course, heat pump is different than a combustion engine, but it's both piston-based, and there's a lot of synergies which we can use mainly in supply chain development, engineering, and service and maintenance. On the right-hand side, you see currently our offices. So we originally founded in Norway, but now most of our business activities moved to Remscheid, which is in Germany, close to Cologne and Düsseldorf. There we have our global headquarters, the R&D, sales, and service. And as well as mentioned, we also will build and hire more people also in Jenbach at Inyo. And there we also will build one of the biggest closed-loop heat pump test beds, which is able to test the capacity up to 10 megawatts, so which is built for the HBL16, which we will launch shortly and which will be operational from summer next year on. Going a little bit more to the technology, here you can see our product portfolio. We have an operating range on the heat source side between 10 and 150 degrees. So it's not only a high temperature heat pump when it comes to the heat sink side, probably from the technology point of view, even more challenging is the heat source side, especially dealing with very high inlet temperatures. And on the heat sink side, we are focusing really on the higher temperature market. So starting at 90, 95 degrees, and then go all the way up to 200 degrees. Of course, also knowing that there are complementary technologies like MBR in most cases, it might be also only relevant to supply 140, 150 degrees. I come to this later on. Here you see the two products. Left-hand side is the HBF4, which is mounted on a skid. On the right-hand side, the HBS16, which will be so big that you have two skids, but it's still the modular approach. So our idea is really that you can do a 1 megawatt pilot and then roll it out to 50 megawatt and more, what you need. So it's really a modular and flexible capacity approach, because we are convinced that when we want to bring costs down, that we need to have a modular approach. And also to build up trust at customer side, it's good that you have the option to test, for example, a 1 megawatt pilot machine, but then can scale up with the existing technology platform to more than 50 megawatt, what is then needed. And you will see later on that's a typical case for the sugar industry, so for the pulp and paper industry, for the chemical industry. They would like to start maybe with a small size heat pump, but then would like to scale it up and do not want to use candle lights to really make then the 2-digit megawatt range. What is important and what I would like to highlight on the heat booster technology is the piston compressor technology, because we are convinced that also flexibility is key for the market. So we can go down to 20% of the nominal load with the same efficiency, and 30, 40, 50% even with a higher efficiency of the load. And we can also deal with or we can also enable fast load changes. So fast for us means in the range of 30 seconds from full to part load. And this also enables us to do grid balancing. Yeah, so grid balancing not only day ahead, but also in the intraday market, in the 50 minutes market, that you can also optimize the costs. And if you optimize the electricity costs, you also optimize then the COP in the end of the day. Yeah. And with this modular system, we can also enable redundancy. When we would, for example, install 5 or 6 heat pumps, we would not switch one off. We would run all of them in 70 or 80% part load in our sweet spot, where we have even increased COP and efficiency. And for maintenance reasons or for redundancy reasons, we can still ramp the others up. So that's really our philosophy, installing multiple machines on site. Coming to the working fluids, we can run with a lot of different HFOs and hydrocarbons. So that's, I don't now want to open up a discussion. We do have preferences in the market from different customers, and both of them have, of course, advantages and disadvantages. We are currently not, or what our compressor can currently not do is water, CO2. Ammoniac, it could in theory do with the small adjustments, but this is more for at least this, subcritical processes for the lower temperature end. So we are really focusing, as mentioned, at 90, 95 degrees plus, and then we use a different set of working fluids. Maybe one point which is also worth mentioning, it we cannot deal with the same hardware using different HFOs and hydrocarbons. It's also possible to start with HFOs and then switch over to hydrocarbons. We call this hydrocarbons ready. This, of course, is then you also need to have a project preparation that you also do the other towards hydrocarbons. Yeah. So, but from the technology point of view, from the hardware, it's fairly simple to switch over from HFOs to hydrocarbons. The piston compressor with this variable compression ratio doesn't care too much about the different evaporation curve. Of course, a few sealings and so on needs to be exchanged, but the hardware ready is in general prepared for both using HFOs and hydrocarbons. But now let's come into the more exciting point to see the heat pumps in action. Here you see a quick overview of the different references we have, which we are allowed to also to publish. We also now have a few more, or will have a few more, which we are not allowed yet to publish. We are working on this, but it's also like what we have heard before. It's not always just to get the references, it's then also that it could be disclosed that we also can share the knowledge and also the references, because as we also heard a few times today, it's really needed to also build trust for the broader customer base. Starting with Beneo, this is, let's say, for us more a low temperature case. However, the customer in this specific case was interested to have a very high temperature lift, so he wanted to preheat the drying air as much as possible. And this can be done with a single stage from 20 all the way up to 95 degrees. We are using here an HFO. And the main purpose was not only here to save CO2, it was also to avoid the installment of a cooling tower. So the customer was also focusing to cool down the temperature of the influent water, because in Europe you are not allowed to release it with higher temperatures than 25 degrees. I think more exciting from the heat pump point of view is for sure the Südzucker cases here. That's the first one in the crystallization in the sugar house in Offenau. And here that's we have still a closed loop heat pump. That's not an MBR. So we are using steam as heat source and steam on the heat sink side. So we condense the steam directly in our heat pump and evaporate at the same time our refrigerant. And on the right-hand side, on the heat sink side, we evaporate the steam with a steam generator and condense the working fluid in the plates. And by this, we're reaching a maximum flexibility and can also do quite large lifts in a single stage. And second application at Südzucker, which is part of the evaporation station, is with a higher heat source and a higher heat sink temperature. And of course, in the future, there's also be the option to combine these two applications even in one. So doing the temperature lift, which we're now doing with two stages from 60 to 100 and 100 to 130 in a single stage, so from 60 to 130. And then we would only need one stage and not multiple stages. And this makes it more flexible also in terms of integration. In this particular case, we are now producing 4 megawatt with the two smaller machines with the HBL4s. and the steam output amounts approximately 6.6 tons per hour, and we save 2,660 tons of CO2 annually. That sounds not that much, but please keep in mind that the sugar process is only in a few months per year. So it's a sugar beet process, which is typically starting in September and ends in January. Yeah? And as we are speaking, we are currently commissioning these machines. So these are real customer applications. This project, probably a few of you have already heard about. This is part of the ETHOS EU funding project. And here we will do it with our partners Felix Schöller, the paper company in Osnabrück, and the DLR. And here we will use as heat source, very typical for the pulp and paper industry, 40-50 degrees heat source. And then we condense the moisture air, transfer it to a intermediate water loop, and then we do it also here with a single stage, compress it to the working fluid to 120 degrees steam. So the working fluid is in this case isobutane, and we produce also here directly steam, saturated steam with a pressure of 2 bar. And this 120 degrees is then supplied to our partner, to the DLR, which then compress it with two turbo compressors as MDR. And this, and also the example before from the sugar industry is I think one of the best reasons to also consider our technology, because with our technology you have this chance to do this 1 megawatt pilot and then roll it out to the 2-digit megawatt range, because neither the sugar nor the paper industry is in the end of the day interested in a 1 megawatt pilot. They would like to have 2-digit megawatt range, which you only can do then with the 16 cylinders, which you will see here. That's also an EU funding project from ArcelorMittal. And here, this is the first time that we will deliver a 16-cylinder machine. That's the HBS 16 water. And here we will use the heat source from 70 to 55 degrees, which is the waste heat of ArcelorMittal in Belgium, in Ghent. And then we will supply this to a district heating hub, which will operate between 110 degrees to 125 degrees. Sorry for the mistakes. The arrows are, of course, wrong. The red arrow should be with 125 degrees, the yellow one with 110. This temperature lift is quite big, and also need to admit that the working fluid is an HFO here. Actually, from the power performance, it would be better to use an isobutane here, because that would also enable us to have more power output. In this particular case, the customer don't need more, and he definitely wanted to have an HFO, a non-flammable working fluid. That was the decision taken. But of course, and we could also use here isobutane, and then we would reach a thermal power output of around 6 to 7 megawatt with a single HBS 16 machine. Last but not least is, or the second last application is the plasterboard drying. That's not a steam application like the one before, but I just show it because it's also a project which we sold and which we will deliver next year. And these are actually now this plasterboard example, but also the distillery example later on. They are both applications which we now do in hot water, but and both are greenfield installation. But actually, for brownfield, it was as usual with steam discussed. So this application with steam would then require a temperature of 120, 130 degrees. With water and greenfield, of course, we could manage to bring down the temperature lift quite significant, which also enables us to reach this high COPs. And honestly spoken, we also saw it before. These high COPs are more or less needed in Germany, because with a COP of 3, it might be challenges and only fly probably with incentives. but this application could also be done with our water steam heat pump, and then typically 120 to 130 degrees steam is needed. Similar to this application, here we deliver also an HBl4 water. That's also a greenfield, which is quite innovative on the distillery. Here we will also publish soon more details, where it is located and who it is. And here it's also very interesting. When you do it in brownfield, you would need 145, 150 degrees steam. So you can also do it. But this project is in UK. And let's say with a COP of around 3, which you would reach when you do it with steam, it's probably hard to get the economics nowadays in the business case. Let's wrap it up quickly. So why Heaten, or what makes us special? I think we have now long-term experience, especially starting from the organic ranking cycle. So all the learnings with oil treatment and the different working fluids are gained already long time ago. We have now, since last October, really reliable partners with us, which not only short-term financing, finance towards the next milestone. Now we have really a long-term, multi-generation product plan also in place, which enables us to have the financing the next 4 to 5 years. And we also have Inyo Jenbacher, which enables us support in terms of engineering, supply chain, integration. So we can also now do a turnkey project if needed, if the project is strategic enough for us. And that's, of course, a completely new capability which we now have on board. Our technology is future-proof, so we can use both HFOs and hydrocarbons. As mentioned, we can go from a pilot to a full industrial rollout, and we have a long service life time. So with one major overhaul after 10 years and a minor overhaul after 5 years. And the technology is really made to bring the flexibility in the megawatt range. So really have a high part load efficiency, can go down to 20% and below this, and reacting very quick on different process conditions. That means temperature-wise, but also from the power range, and also make it operational into the intraday market is also needed, I think, also to really cover the main challenge that also electricity is not always cheap, is not always there, or not in the scale, because the 16-cylinder, we are easily talking about, let's say, 2 megawatt electrical consumption per heat pump. So you also need to have this flexibility on the consumption. And last but not least, we have really developed this piston compressor from scratch. So we own the full IP and the whole heat pump, and this makes us also flexible towards market needs and can adjust it to customer needs. And now, thank you for your attention, and I'm also happy to answer some questions. Thank you.
Thank you very much, André, for this very well overview of Heaten.